Thank you for a very nice presentation about pumping. Now I will continue with a new concept for gentle and effective catch handling and storage of pelagic fish. And this principle is based on under pressure and pressure. It's developed together with the MMC Tendos, and we've had financing from different sources, from FOF, the Norwegian Research Council, Innovasjon Norge, and SkatteFUNN. So it's been a large project going on for 8 years, and we started out in the early 2000s. So the main goal of this project was to develop the future system for loading and chilling of and unloading of pelagic catches, and mainly we started out with the purse seiners. We want gentle and effective processes from fishing gear until landing, and automatic solutions replacing heavy operations carried out by fishermen. And we wanted a flexible vessel that allows for all year running, and this means a multi-purpose vessel. So this vessel is also working offshore for the oil industry and for different research purposes. As Leif told you earlier today, this is the triangle that we run our projects through. We have the end user and the equipment vendor, and us as a research partner, and also, of course, with the other national and international partners. In this project, we've been working with different ship owners, but Ervik and Sævik, they have installed the new equipment now. The vessel is 2 years old. So we've worked together with the MMC in all phases, from the idea through the design, testing prototypes, proof of concepts, and then until we have the vessel. And we've done tests on the vessel with the equipment installed. The new concept is, as I told you, loading by negative pressure. We want an effective loading, avoiding pump blades that can cause damage to fish and bloodspots in fillet. We have a water separator with a larger drainage area than what is typical to have an effective separation of seawater and fish. We have cylindrical RSV tanks with a good flow pattern to ensure rapid chilling, and we have automatic cleaning of tanks to improve the HSE for the fishermen and for improved hygiene. We're also working on an automatic solution for fish sampling and single fish weighing, which is to have an accurate weight estimate, which is given to the buyers in the auction. So this will be an easier operation for the fishermen, and of course we also want to weigh more fish so we can have more accurate numbers. This is in black because it's not finished yet. We're working on that. And we have a system for unloading of catch by pressure instead of vacuum systems. And this can avoid some typical damages that you will have by using the flaps valves. Here you see a picture of the system. You're loading. This is the water separator. So the underpressure is actually in the whole system. And this is for those of you who know the aquaculture, we have the well boats. It's something similar, but of course here you need to separate water and fish, so that complicates the system. And the lifting height here is much higher than in well boats. It can be up to 8 meters. yeah, there's a lot of details here, but I'm not sure. Of course, everything is automated, so both the skipper and the machine engineer, he sees everything on screens and follows the whole process for the unloading. We have done several tests on research cruises, and this was done in 2010. It's quite difficult to do these kinds of experiments because, as you know, there's many factors when you are fishing, like weather and weather conditions, and of course the catch size, and yeah. So, but we've done a lot of tests, and we have some numbers on the quality effects. Here you see the old water separator, and here is a prototype of the new. This is before we used under pressure. This is an open system. But you see the design of this water separator here. So then we loaded catch from the same catch. We used both water separators, and we evaluated the bloodspots on the herring fillet. And the way we did it was that we took pictures of many fillets, and then we put them all together. We didn't group them, and evaluators were looking at all the fillets, grouped them into different grades of blood spots. It's not that easy to see in this picture, but we have a scale from 1 to 10, where 10 is the worst fillet. And the results from this study, here you see that these are the best fillets, and these are the worst. So the traditional water separator had more of these fillets with many blood spots, where the new design had less. So we see that this design can actually help improving quality. Do you have any questions? Or no?
It was just interesting that the bad ones is a little better, but the good ones is a little worse for the system. For sure.
Here you see the new design have most of these good fillets.
Yeah.
Yeah, and less of this worse.
So it's the number where.
This is the percentage of fillets within each group.
Okay.
It's a bit complicated, this graph, but I hope you understand. And if not, please just ask. And we were in another research cruise. We were checking the loading system and the unloading system. Here you see the typical fish pump, and this is just a drawing of the new system. And here is the vacuum pump for unloading, and this is how we unload by pressure. And then we evaluated the percentage of damaged mackerel after landing or catch. This is the amount of the damage, and here we have the different types of damages. We have evaluated the total amount of catch damages, but also the different types of catch damages, since we know where some of these occur. For instance, the flap damages, they are caused by the vacuum pump during unloading. And we evaluated under pressure and pressure. This is the new concept. Then also the under pressure and the traditional vacuum pump, and the traditional ball pump and the vacuum pump. What you can see is that this vacuum pump causes the flap damages, which are not seen in the pressure loading. You may think that 0.35% of fish is not very high, and that's true. But if you think about all the catches landed, it's quite a lot of fish. And for a typical catch of 1,000 tons, this is 3,500 kilos. So it adds up. And as I said, it's difficult to do this kind of studies, and you can see that these numbers using the traditional system are lower than these numbers using under pressure and vacuum. And that's because these are two different catches. We are not able to evaluate all systems on board the same boat at the same time. And that's, of course, a problem for the design, but it's the only way we can do this kind of studies. And we know it's varying between catches, but these two systems have been tested on the same boat at the same time. So we can compare them directly. And here we need more numbers to confirm.
Is that the mackerel you see there?
These are herring. So yes, but the same damages occur for mackerel.
Okay.
So I'm sorry I didn't put the mackerel pictures. I have them. So. Then the new concept is installed on board the Christina E vessel, built in 2011. Here you see the tube and the gear. And we have an automated system controlling the loading of the catch. And also we have a camera system where they can follow the catch in the tube during loading. And I hope I turned off the sound now because this is a bit noisy. Yes. Here you see it's light behind. So when it's black, there's a lot of fish, and when you see the light, it's little fish. So they use this to have an effective loading, because normally the system is open and the skipper can see, and there's a lot of noise during loading. But this system, it's totally closed. So it's for the fishermen, it was kind of a new way of working, and we are helping them to have some tools just to be able to follow the process during loading closely. So this is one of the things that we have installed. We also work with different sensors and cameras to help them with this operation. We tested the whole system on a research cruise in September 2012, catching Norwegian spring-spawning herring, and we evaluated the raw material quality after landing and compared with other vessels from the same field, fishing on the same field at the same time. This is a lot of data, but I won't go through it. The key is the Christina E with the new system, and the others with the traditional system. Here is a picture of herring with the Bloodspots, herring fillet. You have small, this is how we graded them, small Bloodspots, larger Bloodspots, red neck and red tail, which is a typical quality grading. We couldn't see any significant differences between the Bloodspots in this case. You see some trends, but no significant differences. However, we've been looking at the hardness of the fillets, and there's significant differences between the unloading by under pressure and the traditional system. You see, these are the best fillets, And these are the softer fillets. And I'm sorry that I don't point on your side. Just tell me if you... These are the softer. And Christina, I had the best quality regarding the hardness of the fillet. Also, the gaping of fillet was more pronounced when we used the wane pump.
But is it the same? Is it the same? The herring caught in the same area?
Yeah, the same area, the same fishing ground.
Yeah.
The same time before landing.
So it's nothing to do with the different type of.
No, we have tried to control it as good as we can.
Yeah.
And this is hidden, but of course you see, the 0 is the very best, and 1 had small gaps, so we didn't see any bad quality fish here. Most of the fish were very of high quality, but small gaps was more pronounced in using the wane pump. Then we have some feedback from the industry after landing of catch. Of course, we as researchers, we can have a look at as many fillets that we can wish and hope for a day, but the feedback from the industry is what counts in the end for the vessel owners. So they are of course very happy when they have this kind of feedback. Yes, actually, this guy said that some of the mackerel was actually swimming when it was delivered. So they have never seen that before. So we haven't investigated that any further, but yeah. And they have a report, I won't go through that. And for further work, as I said, we're working on this automated fish sampling and weighing of single fish. This is just a drawing of the machine that we will build, where FOF is financing the project and MMC is going to build a finished product. And we've been on a research cruise. I just came from this cruise and here, testing this step. We want to take out batches, immobilize the fish, singulate it, and then we have to detect if they're coming one on one before we weigh them and put them back into storage. So this immobilizing, since we worked a lot with electricity, that's the first thing we've tested. And now we're not talking about the stunning, but we want the fish to lay still. And of course it's important that we have a good quality of this fish after this immobilizing step, since it's going back to the fish tanks and will be sold. So I only have pictures now from this cruise. Here we store live fish before it's stunned in this bucket. This is the test. And we're evaluating if it's moving. And also, of course, the quality, looking for broken backbones. And this was a mackerel cruise, and the mackerel was behaving very well. We didn't see any backbones broken at all. Testing different frequencies, different voltage and currents. But we got some herring in the same catch. Then we had to try herring, of course, and we see that there's some more problems there. So we will continue that work. But the good thing is that mackerel can take many different frequencies. So we will have a system working for both species. So that's all. Thank you, and please ask.